In this video, I'm going to do an example where we have a poker hand and we're trying to find the probability of certain hands that you have in your poker hand. Okay, so in a poker hand, you have 5 cards. Okay, so you need to know that in order to solve these problems. So we have 5 cards in our hand, and first thing we want to know is find the probability of getting 4 clubs. So you basically, so let me go ahead and write that down. So we want the probability of 4 clubs. So that basically means you have 4 clubs and then 1 other type of card. Okay, so what we want to do is, we'll go ahead and say the number of ways you can get 4 clubs divided by the total number of ways you could get 5 cards, right? So number of ways to select 4 clubs. Now I'm going to have 5 cards, so 4 clubs and 1 other card, right? So other means not club, right? And then divided by the number of ways to select 5 cards, right? This is like the classical approach to probability. Basically, the number of ways that your outcome can occur divided by the total number of possible ways that the experiment could have happened, right? So number of ways to select 4 clubs. Now when we're thinking about that, you need to remember that this selection happens without replacement, right? It's not like you get 1 card and then they put that card back and then give you another card. No. So because it's happening without replacement, and it really doesn't matter the order that you're getting your clubs, right? If you get a 1, 2, 3, 4, or a 4, 3, 8, 2, they just need to be clubs. It doesn't matter the order that you're getting them or which clubs they are. So we're going to use combination for that because the order doesn't matter and it's basically sampling without replacement. So how many clubs are in the deck? Well, there's 4 different suits, right? And 52 cards. So 52 divided by 4 is 13. So we have 13 possible clubs and we're selecting 4 of them. Now, how many cards are not club, right? Well, there's 52 cards in the deck. 13 of them are club. So that leaves us with 39 non-club. Okay, so we have 39 non-clubs and we're choosing one of those guys. Okay, then we need to select 5 cards from the deck. Well, there's 52 and we're choosing 5 of those guys. All right, so you can simplify this and solve. All right, so now what if we're doing 4 clubs and 1 heart? So basically this changes our numerator a little bit. The denominator is still going to stay the same. So what we want to do is number of ways to select 4 clubs and 1 heart divided by number of ways to select 5 cards. Okay, students actually usually do better on this type of question than they do on this one. And the reason why is a lot of times people neglect that they're getting 5 cards, so they forget about this 39 choose 1. So don't fall into that trap. Make sure that how many you're choosing in the numerator should add up to the total number that you're choosing in the denominator. So if we're choosing 5, you need to be choosing 5 numerator and choosing 5 in the denominator. Okay, so here it tells us very clearly we're selecting 4 clubs, so this is the 13 choose 4, and then we're choosing 1 heart. Well, how many hearts are there? There's 13 hearts, so now it's 13 choose 1. So instead of it being 39, because basically that could have been any other card, now it needs to be a heart, so it's going to be 39 choose 1. And then we have 52 choose 5. All right, so you can simplify that and solve. So hopefully this helps solve your type of problems with finding the probability of certain poker hands. If you have any additional questions or maybe I didn't clearly explain all the steps, please let me know and I'll talk about it in more detail.